All right, we got the Hercules 20 volt, or really 18 volt Harbor Freight battery here, the new line. And I'm going to show you a little bit inside, and I'm going to show you how you can adapt these to be used on DeWALT 20 volt line. So first off, it's just a couple, I think it's a T10 fastener here. We'll take these off. The dimensions aren't perfect, but they're close enough. And whoever designed this battery probably took a lot of cues from the DeWALT battery here. Here's a DeWALT battery here, so you can see they're real similar. The pinout is identical, so they're real similar design. The country of origin on this is China, as expected from Harbor Freight. Last screw out here, open her up. The construction of it is it's PA6 glass fiber reinforced 15%, so it's pretty stiff. It's what you find on all your tools, DeWALT tools, Milwaukee. Everybody's using the same exact plastics. Same as the bottom. It's a glass fiber reinforced 15%, and it actually has kind of a TPU overmolding here, so it's a nice little rubberized coating on the bottom. But inside here, you can see we have Samsung cells, Samsung 2500 milliamp hour cells. We'll get this to focus. There we go. It has an aluminum heat sink, so a lot of the earlier DeWALT batteries also had this. They ditched it after a little while. Not sure why, but it has an aluminum heat sink here. But yeah, just 5 cells in series, just like, we'll take this DeWALT one apart real quick. And we'll do a little comparison inside. I'm really not too surprised that they're using Samsung cells in this. The pack itself, I believe I bought it $30 US. So they're about on par with pricing of a DeWALT pack. T10s out. We'll crack open this one here. You can see this one also is. Oh, this is actually ABS. So this is just ABS. Kind of cheap for this. This glass fiber reinforced is actually a better material. And we'll pop this out here. And you can see these are, you probably can't see, they're Sanyo cells in this, but just the same. Sanyo, Samsung, Panasonic, they're all they're all the big manufacturers of lithium-ion cells these days. I think the country of origin on this one, I believe it's Japan. But just comparison, this does have quite a bit more logic here on the little circuit board. But it is directly connected, so we have our positive and negative pole here, and they're directly connected, so there is no overcurrent or undercurrent protection. These two are always hot all the time. There's no way for the circuit board to actually turn that off. You can see we have balancing, the balancing leads here go to this board. So this board is definitely a balancing board. Got a bunch of little resistors here, little capacitors. It does have a, this is the first time here, it has a little thermistor here that fed into the pack itself. And then it has this little fuel gauge here, just a little voltmeter just connected. The main difference is, here's the DeWALT pack here. You can see that the positive and negative are actually wires themselves, probably about a 14 American wire gauge, 14 or 18 American wire gauge, soldered on, as opposed to all the current right here is running through this, probably a single layer, maybe double layer PCB. It's got to be a double layer PCB. So a little bit difference in that. This can certainly probably conduct a lot more current than this can. Of course, these tools probably, I think they're rated for about 25, 30 amps. And you can see under here they have a little mica sheet for insulation. But construction-wise, very, very similar. But definitely, I believe there's a little bit more passive components here. There's a little IC, integrated circuit there. And we can flip this over here. We'll grab a... All right, we got the desoldered all the legs here on the PCB, and you can see basically all of the legs pretty standard, and they're all connected to the balancing cell. One thing that surprised me a bit is that this here has a marking here, PA6 glass fiber reinforced 30%. So this is real pretty expensive here to reinforce glass fiber with 30%. It's normally what you see on the tools of the body. You don't usually see it here, so you didn't spare any expense there. Celastic here on the little thing that we pull out, little thermistor. It was Celasticed in there, and you can see also around all this we have Celastic holding all this stuff together. So pretty well, very well built part, I would say, on the build quality here. On the PCB here, we can see this is a little bit. We'll talk about that later. A little bit of my customization. The solderings all looks, you know, good. It's all wave, probably just all wave soldered. Doesn't look like any hand job here. So, said this is just held on by two little wires. So basically, what the trick here is, on the case, obviously physically we have to modify the case a bit. You can see we had to kind of slot this out a little bit more. Had to kind of do a little sanding, a little grinding on the case. To get it to physically fit in the tool, and grab a tool here real quick. We got a hammer drill here, or not the hammer, yeah, the little SDS drill, and you can see obviously the here's the OEM case, DeWALT battery here. I can slide on here. And you can see it engages here. We have 2 pins. We have our two, so all the tools, they have the 2 pins here, and then they have 1 pin. Not sure what it does. The other pin is the temperature sense pin. And how those work on the DeWALT battery here. I don't have my multimeter here, otherwise I'll tell you. This pin right here is your temp pin, temperature sense pin. And what it does actually on the positive side, it's resistance from the positive of the battery to this sense pin is at room temperature here. It's about 78 degrees. It's about 10 kilo ohms. So that's how the tool does temperature checking, right? It'll shut down the tool if it finds that the battery pack is too hot. So by default, the way the Hercules battery works on the temp sense pin, so this is the same pin, same temperature sense pin here. And basically how the Hercules tool works is that it checks resistance across ground to this temp sense pin, and it's about 100 kilo ohms at the same temperature. And it uses this little thermistor and does that. So, how we get this to work is if you obviously make all the physical modifications, the tool simply won't turn on. It'll think it's either overheated or under or too cold. So what we have to do here, as you can see what I did, we soldered a 10 ohm resistor or 10 kilo ohm resistor here between our temp sense pin, this one right here, and our positive here. So this doesn't carry any current. It's just a little quarter watt resistor. Doesn't carry any current or just very little current. So after adding that 10 kilo ohm resistor to work on the tool, so we'll put this back together, solder it up real quick, and we'll throw it on the tool and show you that. All right, so we got the Hercules battery all put back together, and you can kind of see a little bit of the modification here. Not a whole lot. The only downside is that the distance. We'll grab the other battery here. You can see the distance between the retainer here and the terminals are different, slightly different, about a centimeter or so. So the clip is not as positive as I'd like, but like I said, just for experimentation purposes, that's what we got. So if we put the Hercules battery into the SDS drill, we can see, no problem. Works perfectly fine. So that's the main thing you got to do. Add 10 kilo ohm resistor to get the tool to accept battery. The only downside, obviously, is you won't have any thermal protection, so you got to keep that in mind. But in reality, this is a $30 battery, and I think you can pick these up for $30, same price. So it's not a real practical thing, but if you don't have access and you can run down to the Harbor Freight and grab one of these, a little know-how, you can make them work in all your DeWALT tools.